All right, so here we're on chapter 4 on section 2 on systems of linear equations and augmented matrices. So, what we're going to do here is we're going to look at matrices. So, solving systems of equations using elimination by addition involves manipulating the coefficients of the variable and the constant terms. Now, this process is actually more efficient using a mathematical form called a matrix. Now, a matrix is basically a rectangular array of numbers written within brackets. Now, each number within the matrix is called an element of the matrix. Say it's matrix A. So here we have matrix A on the left, then we have matrix B here. These are two examples of what a matrix could look like. Now, each number in the matrix, like we said, is an element of that matrix. Now, matrix A has 2, 4, 6, 8 elements, which is 4 rows and 2 columns, and B has 12 elements, which is 4 rows and 3 columns. Now, a matrix is usually written as M by n. So m is going to be the number of rows, n is going to be the number of columns. So this is going to be a 4 by 2, and this one's going to be a 4 by 3. Okay, and so that gives us the size of the matrix as well as the dimensions of the matrix. Now, when giving the size of the matrix, remember the rows is given first, followed by the columns. So that's kind of a key is you always want the m rows, n columns. Now, a matrix having n rows and n columns is called a square matrix of order n. So that'd be like a 2 by 2 or a 4 by 4 or something like that. And a matrix having only one column is called a column matrix. And so that means it's just going to be, maybe 5 rows, but one column. And then we also have a row matrix, which is just one row, but you can have a lot of different columns. So these are kind of what we could see here. So a square matrix, this is a 2 by 2. There's columns and 2 rows. This is a column matrix because we have a number of rows, but just one column. And this is a row matrix because we have just one row, but a number of columns. Now, the position of an element in a matrix is given by the row and column containing the element. And this is usually denoted by a double subscript notation Aij, where I is the row and J here is the column containing the element Aij. And so, if this is our matrix A, this is going to be A11, A21, A31, A41. This will be A12, A22, A32, and then A42. Again, doing row, then the column. Now, note that A12 is read as A sub 12, not A sub 12. Okay, so that's kind of a key. So remember, I was saying 1, 1, 2, 1. I wasn't saying 12 or 31 or 32. It's each number is an individual number because it's a position. Now, the collection of elements AII make up the principal diagonal of a matrix. So in this case, the principal diagonal, this is going to be A11, and this is going to be A12. So in this case, like we show here. All right, so we can also plug matrices into calculators, which is really nice to do some calculations. And so most graphing calculators rather are capable of storing and manipulating them. And matrix A input into a graphing calculator is showing. So if we have this matrix up here, we can put it into the calculator here. And this is A32. So this would be A sub 3 comma 2. So that's kind of how it is, and this is how it's labeled here is with the 3 comma 2, whereas before we would have A sub 3 2. So there's a difference in how things are labeled, but that's how it would work. Now let's not stop here, but let's go to show you how actually to get to that to the calculator. So what we would do is we do second this, which is second matrix with the blue button. These are going to be all the matrices. This is the math that we can actually do on the matrices, and this is how we input a matrix. So let's go over here and talk about inputting a matrix. So let's say we want a 3 by 3 matrix. So we could put a 3 and then enter and then a 3. Now we have a 3 by 3. And what we do is now we just type the numbers. So say 7 is in 1, 1, and then we can have maybe a -2, a 3, and then a 4, a -9, 5, 0. 2 and a -7. Okay, and so that's going to be our matrix input. And again, this is position 1, 1, and if we move down, that's 2, 1, 3, 1, 3, 2, 3, 3, and so on. So that's how you do it. And then whenever you're wanting to do something, you're going to have to go back out. So we're going to get out of that. Go back in here. So now A is that. So if we just hit enter A, then we can say, okay, what is A? Well, now it shows you what A is. And then we can do all kinds of calculations with A or B or C or whatever numbers we are, but we're not at that point yet. So let's stop there and we'll come back for some more.